the wind shifts, and in that single breath, the planet reminds you that survival is borrowed time. Heat presses in from every direction. Cold waits beyond the horizon, and the air itself can thin without warning. You are not built for most of this world. You are tolerated by it. In the world's fiercest deserts, sunlight becomes a weapon measured in physics. The ground radiates heat back into your body until your internal temperature begins to climb past its narrow safe range. Sweat evaporates too quickly to cool you, draining water faster than you can replace it. Blood thickens. The heart works harder. Within hours, confusion sets in and the horizon shimmers not with hope, but with distortion. Survival. Here is a race against evaporation. Cross the planet to Antarctica, and the threat reverses, but the outcome is just as swift. Cold does not simply chill. It extracts energy at a relentless gradient. Skin loses heat to air. That is dozens of degrees colder. Wind accelerating the transfer. Core temperature drops by fractions that matter. Shivering turns to stiffness. Stiffness to silence. The body protects its vital organs by sacrificing fingers, toes, clarity of thought. Exposure is not dramatic. It is quiet. And it is fast. Climb high enough, and the danger becomes invisible. At extreme altitude, oxygen pressure falls so low that each breath delivers less of what your cells require. Your lungs expand. Your chest strains. Yet the bloodstream carries only partial relief. The brain, starved of oxygen, begins to misfire. Judgment slips first. Coordination follows. Without acclimatization, minutes can feel like hours, and then the mountain simply waits. In dense equatorial jungles, the threat is not temperature or altitude, but isolation engineered by biology. Humidity saturates the air, preventing sweat from evaporating efficiently. Your body cannot cool itself properly. Insects carry microscopic adversaries. Water sources conceal parasites. Thick vegetation blocks navigation and sunlight alike. Disorientation arrives. Subtly, exhaustion compounds it. Here, the environment does not attack. It overwhelms. Then there are landscapes that seem forged in anger. Volcanic regions pulse with geothermal energy drawn from deep beneath the crust. The ground can fracture without warning. Superheated steam vents from fissures at temperatures capable of searing through protective layers. Lava flows are slow from a distance, but their radiant heat travels faster than footsteps. Even standing near these zones taxes the body's thermal balance. The earth beneath you is not stable. It is alive. Some dangers are lighter than air. In certain depressions and crater basins, heavier than air gases accumulate silently. Carbon dioxide, hydrogen sulfide, odorless or faintly scented, can pool at ground level. You inhale normally, unaware that oxygen is being displaced. Dizziness feels like fatigue. Fatigue becomes collapse. The body cannot distinguish between invisible poison and empty air until it is too late to respond. Water, too, can betray expectation. Hyper-saline lakes shimmer invitingly under the sun. Their surfaces calm and glass-like, but salt concentrations far beyond ocean levels draw moisture from skin and eyes, causing rapid dehydration upon exposure. Ingesting the water worsens the imbalance, forcing cells to surrender even more fluid in an attempt to equalize. The body's chemistry, finely tuned for moderate salinity, destabilizes in minutes. Storm systems gather electrical charge on a scale that dwarfs comprehension. In lightning-prone regions, the atmosphere itself becomes a conductor. Billions of volts seek the shortest path to ground. Open plains, mountain ridges, isolated trees, each can become a target. The human body, rich in water and electrolytes, offers low resistance. A strike is not merely heat. It is energy, overwhelming biological circuitry in a fraction of a second. Even where lightning does not strike directly, pressure changes, and downdrafts reshape the air. Microbursts slam downward with sudden, violent force, flattening terrain and destabilizing structures. The human frame, designed for gravity's steady pull, struggles against chaotic vectors of wind. Balance disappears. Debris becomes airborne. In moments, orientation is lost within a system far larger than comprehension. Across salt flats and toxic basins, minerals crystallize into deceptive crusts. Beneath them, mud can swallow weight without warning. High concentrations of heavy metals contaminate soil and water. Prolonged exposure damages organs silently, molecule by molecule. You may walk across such terrain unaware that the very ground is altering your internal chemistry. The pattern repeats across continents: heat that dehydrates, cold that extracts, altitude that starves, gases that displace, water that poisons, electricity that hunts the tallest point. The human body, remarkable in its adaptability, operates within narrow tolerances. Temperature must hover within a few degrees. Oxygen must saturate within a tight percentage. Hydration must balance precisely. Beyond those margins, systems unravel. And yet these are only the thresholds most people recognize. There are places where pressure itself becomes the adversary, where darkness is absolute, where chemistry and gravity conspire in ways that make deserts and mountains seem forgiving. The further you move from temperate equilibrium, the clearer the truth becomes. Survival is not guaranteed by courage or strength. It is granted by conditions aligning within fragile limits. And beyond those limits, far below, far above, far deeper, into this planet's extremes lie environments where even preparation begins to fail, where the rules grow harsher, and where the margin between breath and silence narrows even more. And beyond those limits, the planet descends into realms where even the concept of preparation begins to fracture. Far below the surface of the ocean, sunlight disappears and pressure multiplies with crushing indifference. At hydrothermal vents, seawater superheats as it seeps into Earth's crust and erupts back into the abyss in mineral-laden plumes hotter than boiling water. The surrounding pressure keeps the water from flashing into steam. But a human body, unshielded, would be overwhelmed instantly. Temperature and pressure combining into forces. Our tissues were never designed to endure. Deeper still lies the Mariana Trench, where gravity stacks miles of ocean overhead. Pressure there exceeds 1,000 times what you feel at sea level. Every square inch of the body would face compressive force beyond structural tolerance. Lungs cannot inflate. Air spaces collapse. Even specialized submarines require reinforced hulls to resist implosion. Down there, survival is not a matter of endurance. It is a matter of physics. Denying permission. On land, danger can pool invisibly in volcanic crater lakes perched high within dormant calderas. Beneath their calm surfaces, carbon dioxide can accumulate in massive quantities, trapped by pressure and temperature layers. When disturbed, the gas can erupt silently, spilling over the rim and cascading downhill. Because carbon dioxide is heavier than air, it hugs the ground, displacing oxygen. Breath becomes ineffective within moments, not from poison, but from absence. The body reaches for air that no longer sustains it. In regions scarred by nuclear catastrophe, another invisible threshold exists. Radiation cannot be sensed directly by human nerves. It passes through tissue, disrupting cells at the molecular level. Acute exposure overwhelms biological repair systems designed for background levels, not concentrated bursts. DNA strands fracture. Organs struggle to regenerate damaged cells quickly enough. The danger is not dramatic in sensation. It is cumulative, silent, and unforgiving. Elsewhere, methane seeps from fractured earth and thawing permafrost, collecting in low-lying pockets. The gas itself displaces oxygen and ignites with minimal spark. Ground saturated with it can become unstable, collapsing under weight as trapped gases shift beneath the surface. A step that appears secure can liquefy into movement. Stability here is temporary, dependent on pressures hidden below. There are landscapes that masquerade as solid ground, but behave like fluid. Quicksand forms when water saturates fine sediment, reducing friction between grains. The mixture cannot support sudden weight. Struggle increases liquefaction, causing the body to sink further until buoyancy stabilizes it only partially. Escape demands slow redistribution of weight and leverage. Movements counter to instinct. Panic accelerates failure. At sea, rogue waves rise without pattern, sculpted by the chaotic interference of swell systems and shifting currents. Walls of water tower, far above surrounding seas, carrying mass measured in thousands of tons. When they collapse, the force rivals, structural load ships are not built to withstand. A human caught in that turbulence faces rotational forces and impact pressures that disorient within seconds. The ocean does not need duration to overpower. It requires only momentum. In desert basins that sit below sea level, heat collects and stagnates. Air trapped in depressions warms beyond surrounding terrain. Unable to circulate efficiently, toxic minerals concentrate in the soil and evaporating pools. The body loses moisture rapidly under relentless solar radiation, and electrolytes imbalance as sweat evaporates into superheated air. Core temperature climbs with frightening speed when convection fails to provide relief. Beneath volcanic regions, superheated caves form, where geothermal energy seeps into subterranean chambers. Air temperatures can exceed what skin can tolerate within minutes, humidity approaching saturation. So sweat cannot evaporate. Without evaporation, cooling mechanisms shut down. The body's internal thermostat rises unchecked. In such confined spaces, there is nowhere for excess heat to disperse. Endurance narrows to moments. Across polar ice fields, crevasses open, like fractures in glass. Snow bridges conceal them, thin layers disguising vertical shafts, plunging into blue darkness. The hazard is structural instability, weight applied to a surface that cannot distribute it. A single step transfers force beyond tolerance, and gravity completes the equation. Rescue becomes exponentially more difficult. As depth increases and temperatures drain strength, even glaciers themselves move with slow violence. Ice masses grind forward, cracking and shifting under internal stress. What appears static is under constant tension. Pressure ridges form and collapse without warning. The human body, balanced delicately atop shifting mass, is vulnerable, not only to cold, but to motion beneath its feet. In certain coastal margins, tectonic boundaries generate sudden vertical displacement of seafloor. Water above responds instantly, forming tsunami waves that travel at jetliner speeds across open ocean. In deep water they appear modest, but as they approach shore and compress, energy rises upward. Impact combines speed, mass, and momentum into a single advancing wall. Biology cannot negotiate with that scale. Far underground, oxygen-poor caves and abandoned mines accumulate gases that render combustion impossible and respiration ineffective. Without airflow, carbon dioxide and other gases linger, altering the breathable mixture A few breaths in such an environment can trigger dizziness, loss of balance, then unconsciousness. There is no scent to warn you, only chemistry. And yet all of these places exist on the same planet that sustains forests, coastlines, and cities. Survival persists not because Earth is gentle, but because narrow bands of temperature, pressure, and composition align just precisely enough. Step beyond those bands, downward into pressure, upward into thin air, inward toward heat or outward toward radiation, and the illusion of permanence fades. The line that keeps breath steady is thinner than it appears, drawn delicately across a world that is powerful, indifferent, and vast.